Welcome to online chemistry class. My name is Sharad Panchagalli. Today I am going to discuss about the phenols. So phenols are one of the important class of organic compounds. So first we'll see what is the definition of phenols. So phenols are the aromatic hydroxy compounds in which hydroxy group, that is OH group, is directly attached to aromatic ring. So whenever the hydroxy group is directly bonded to the aromatic group, that will be known as the phenol. So the general formula for the phenol is AROH. So AR is the abbreviation of the aromatic group. So here aromatic group is directly bonded to the OH group, that is hydroxy group. So this will be the general formula for the phenol. AROH is the general formula for the phenol. And we know the simplest aromatic compound, that is benzene. In benzene there are 6 carbons. Each carbon is attached to one hydrogen atom. So we can write the structure of benzene like this also. So this is also benzene. These two structures are equivalent structure. Now when we replace one of the hydrogen of the benzene by OH, so we'll get such type of compound. So here OH is directly bonded to the aromatic ring, so this will be known as the phenol. Now we can write the abbreviated structure for the phenol. So for that purpose we have to ignore these 5 hydrogen atoms. So we have to hide these 5 hydrogen atoms. So we get such type of abbreviated structure. In this structure also the OH group is directly bonded to the aromatic ring. So this is phenol. So these two structures are equivalent. Now in short we are going to discuss the nomenclature of the phenol. So simplest member of the phenol family is also known as the phenol. Phenol is class of organic compound, as well as phenol is name of this compound. Now the carbon adjacent to carbon on which hydroxy group is present is known as the ortho position. The alternate position is known as the meta position. Opposite position is known as the para position. So this is the ortho position. Adjacent position is ortho position, alternate position is the meta position, opposite position is the para position. Now in IUPAC nomenclature, the carbon on which hydroxy group is present will be given number 1. So this is the position number 1. Adjacent position will be 2, then next will be 3. Like that we are giving number to the aromatic ring. Now we'll see certain examples of the phenol. Now this is the example of phenol in which at ortho position there is methyl group. So this is the ortho position. So this will be known as the orthomethyl phenol. Its common name is the orthocresol. Now in IUPAC nomenclature, the carbon on which hydroxy group is present is position number 1. Next position is position number 2. So at position number 2 there is methyl group. So IUPAC name for this compound is 2-methyl phenol. Similarly, in the next example, this is the ortho position. At ortho position there is chloro group and the compound is phenol. So this is known as the orthochlorophenol. According to the IUPAC nomenclature, the carbon on which hydroxy group is present is position number 1. Adjacent position is position number 2. So this will be the 2-chlorophenol. Similarly, in the next example, at ortho position there is methoxy group. So this will be known as the orthomethoxy phenol. Its common name is guaiacol. It is commonly known as guaiacol. Now according to the IUPAC nomenclature, this is the position number 2. At position number 2 there is methoxy group. So this is the 2-methoxy phenol. In the next example, we have replaced one of the hydrogen of the naphthalene by the hydroxy group. Now in naphthalene, this position is known as the alpha position. So at alpha position there is hydroxy group, so this is known as the alpha naphtha. Now in naphthalene, the alpha position will be given number 1, beta position will be given number 2. Like that we are giving numbers to the naphthalene ring. Now in this particular example, at one position there is hydroxy group, so this is known as the 1-naphtha. Now in the next example, the hydroxy group is present at the beta position of the naphthalene, so this is known as the beta-naphthol. And just now we have seen numbering in the naphthalene ring, so alpha will get number 1, beta will get number 2, so this is also known as the 2-naphtha. Now it is not necessary there should be only one hydroxy group directly bonded to the aromatic ring. There may be more than one hydroxy group directly bonded to the aromatic ring. So this is the next example in which two hydroxy groups are directly bonded to the aromatic ring. So the name of this compound is the resorcinol. Now in resorcinol, one of the carbon on which hydroxy group is present is given number 1. So the another carbon on which hydroxy group is present will get number 3. So at 1 and 3 position there are two hydroxy groups, so this will be known as the 1,3-dihydroxybenzene. Similarly, in the next example there are three hydroxy groups. The common name of this compound is the pyrogalol. According to the IUPAC nomenclature, the three hydroxy groups are present at position number 1, position 2 and position 3. So this will be known as the 1,2,3-trihydroxybenzene. Now we'll see the classification of phenol. So depending upon the number of hydroxy groups directly bonded to the aromatic ring, they are classified as monohydric phenols, dihydric phenol, trihydric phenols, etc. So first we'll discuss about the monohydric phenol. So in monohydric phenol, one hydroxy group is directly bonded to the aromatic ring. So the examples are phenol. The next one is the orthocresol, that is also known as the orthomethylphenol or 2-methylphenol. The next one is the orthochlorophenol, that is also known as the 2-chlorophenol. Then next one is the orthomethoxyphenol, that is also known as the guaiacol, that is having IUPAC name 2-methoxyphenol. Then we have this discuss about the naphthalene derivatives also. This particular naphthalene derivative, this is having one hydroxy group directly bonded to the aromatic ring. Name of this compound is the alpha-naphthol. This is also monohydric phenol. Similarly, beta-naphthol is also monohydric phenol. Now we are going to discuss about the dihydric phenol. In dihydric phenols, the two OH groups are directly bonded to the aromatic ring. So earlier we have seen one example. So this is the catechol. So here the two hydroxy groups are adjacent to each other. So the carbon on which hydroxy group is present will be given number 1. Then the next carbon will be number 2. So the two hydroxy groups are present at position number 1 and position 2. So this will be known as the 1,2-dihydroxybenzene. So this is the resorcinol. In resorcinol, the two hydroxy groups are present at position number 1 and position number 3. So its IUPAC name is 1,3-dihydroxybenzene. Similarly, when the two hydroxy groups are opposite to each other, whenever the two hydroxy groups are para with respect to each other, its common name is hydroquinone, that is having IUPAC name 1,4-dihydroxybenzene, as the two hydroxy groups are present at position 1 and position 4. So this will be known as the 1,4-dihydroxybenzene. So hydroquinone is also known as the quinol. Now we are going to discuss about the trihydric phenol. In trihydric phenol, 3 hydroxy group are directly bonded to the aromatic ring. So name of this compound is the pyrogalol. Now the 3 hydroxy groups are present at position 1, position 2 and position 3. So this will be known as the 1, 2, 3 trihydroxy benzene. Similarly, this is having name, okay, this is the quinol. Now what is the difference between these two structures? There is one hydroxy group extra in this particular compound, so this is known as the hydroxy quinol. Its IUPAC name is 1,2,4 trihydroxy benzene. Similarly, when the 3 hydroxy groups are present at position 1, 3 and 5, so that will be known as the chloroglucinol. Its IUPAC name is 1,3,5 trihydroxy benzene. So in this particular section we have seen what is the meaning of phenol. Then we have discussed in short about the nomenclature of phenol. Then we have also discussed about the classification of phenols. Thank you.